In this module, we will look at the aircraft's flight instruments. We will start out with an overview of the flight instrument system. Next, we will look at the air data system, the primary flight display system, the radio altimeter system, the standby instruments, and the flight data recorder. The flight instruments consist of the air data system, the attitude indicators, the altimeter, the airspeed and vertical speed indicators, the radio altimeter, standby instruments, clock, and the flight data recorder. We will start out with the air data system. The air data system consists of 2 air data computers, 2 pitot tubes, 1 pitot-static tube, 4 static ports, and 2 total air temperature probes. The ADCs provide information to numerous aircraft systems. Both ADCs supply pressure altitude, corrected barometric altitude, true airspeed, calibrated airspeed, vertical speed, Mach number, static air temperature, VMO, and total air temperature to both IC600s. The ADCs supply total pressure, Mach number, and total air temperature data to the FADEC. ADC number 1 supplies that information to FADEC 1A and 2A. ADC number 2 supplies that information to FADEC 1B and 2B. Both ADCs supply calibrated airspeed to the Horizontal Stabilizer Control Unit, or HSCU. The HSCU adjusts pitch trim rate as a function of airspeed. Both ADCs supply pressure altitude to the transponder and the TCAS system. ADC 1 supplies true airspeed to AHRS number 1. ADC 2 supplies true airspeed to AHRS number 2. Both ADCs supply true airspeed information to the flight management system. ADC number 2 supplies altitude data to the radar. Both ADCs supply Mach information to the stall protection system. The stall protection system is inhibited above 200 knots. ADC number 1 supplies calibrated and true airspeed, altitude, and vertical speed information to the GPWS. Both ADCs supply pressure altitude, barometric correction, and altitude rate of change to the digital pressure controller. Both ADCs supply altitude trip point information to the ice protection system. Both ADCs supply calibrated airspeed trip points to the rudder system. Both ADCs supply the AWU with the overspeed warning output. The air data system uses various probes and sensors to obtain the information to be distributed to the user systems. These sensors consist of pitot and pitot-static probes, static ports, and total air temperature probes. Pitot tubes 1 and 2 supply total air pressure to the respective ADC. Static ports 1 and 3 are interlinked with static ports 2 and 4 supplying both ADCs. Pitot static 3 supplies total air pressure to the standby airspeed indicator and static pressure to the standby airspeed indicator, the standby altimeter, and the CPAM. Pitot tubes 1 and 2 are located on the top of the aircraft's nose. Pitot static tube 3 is located on the right side of the aircraft's nose. It provides ram and static pressure information to the standby airspeed indicator. It also provides static pressure to the standby altimeter and the cabin pressure acquisition module. Two static ports are located on the lower part of the fuselage on either side of the aircraft's nose. The total air temperature probe 1 is installed on the left side of the aircraft's nose, and total air temperature probe 2 is installed on the right side of the aircraft's nose. Air data system information is displayed on the primary flight display. The source of air data is displayed in the upper left-hand corner of the PFD when one ADC is providing data to both PFDs. Possible indications are ADC1 or ADC2. The label is amber when only one ADC is supplying both sides or each ADC is supplying opposite side systems. The annunciation is removed when ADC1 is supplying the captain's side and ADC2 is supplying the first officer's side. Each PFD displays indicated airspeed, altitude, and vertical speed information. Indicated airspeed and Mach information is displayed on the left-hand side. The information is displayed in a tape format. The speed tape also displays target speeds and the selected speed by means of speed bugs. An overspeed indication bar indicates the maximum airspeed. The overspeed indication bar extends from VMO or MMO. If the aircraft exceeds 250 knots below 10,000, or the VMO 320 knots, or MMO Mach 0.78, the digits in the airspeed window and the digital Mach readout will be displayed in red and an oral warning will sound. If the acceleration trend vector exceeds VMO or MMO, the digits in the airspeed window and the digital Mach readout are displayed in amber. At the conclusion of this audio, we will simulate an overspeed condition. For this scenario, the aircraft is below 10,000 feet. Airspeed information is displayed on a gray moving tape. Airspeeds between 40 and 400 knots can be displayed by means of the speed tape. A magenta trend vector indicates the airspeed the aircraft will attain in 10 seconds provided the current aircraft acceleration is maintained. The trend vector extends from the airspeed lubber line. The vector extends upwards when the aircraft is accelerating and downwards when the aircraft is decelerating. The trend vector is disabled during takeoff. Reference speed bugs are displayed on the speed tape. These reference speeds are V1, VR, V2, and approach. V1 is displayed in magenta. VR is displayed in cyan. V2 is displayed in white, and approach is displayed in green. A reference speed bug is presented when the associated digital indication is selected on the MFD or above 40 knots indicated airspeed on the ground. The reference speed bugs are removed when the aircraft speed is above approach speed plus 42 knots. A reference speed bug may be out of view if the value is too high. The reference bug may be out of view if the airspeed is reduced below 230 knots indicated airspeed followed by an increase above 230 knots. To display the speeds again, press the reference speed buttons. When the airspeed is below 40 knots, the reference speed bug is displayed as a static bug and a digital indication in the bottom portion of the speed tape. The reference bugs are set by accessing the MFD Speeds submenu. This submenu is accessed by selecting the MFD submenu, then the Speeds submenu. Dashes are displayed when the system is powered up. An airspeed is selected by pressing the associated reference speed button. This causes the dashes to be replaced by the speed value, and two white boxes are displayed around the indication. Rotating the reference speed set knob increases or decreases the associated speed value and moves the associated speed bug accordingly. Pressing the associated reference speed button removes the inner box and displays the associated bug on the PFD. The reference speed can be removed from the PFD by pressing the reference speed button a third time. This also removes the outer box on the MFD. The minimum value is 89 knots for V1. The minimum value for VR is the greater of 89 knots, or V1. The minimum value for V2 is the greater of 89 knots, or VR. The minimum value for approach is 89 knots. Pressing the return button on the MFD returns the MFD to the main menu. If any of the speeds are displayed with both inner and outer boxes, pressing the return button removes the inner box prior to returning to the main menu. Click on the return button to return to the MFD main menu. Mach information is displayed below the speed tape. The indication is normally green, but turns to amber when VMO or MMO is reached. The indication turns red when VMO or MMO is exceeded. The Mach number and label are displayed when Mach speeds exceed 0.45 Mach and remains in view until Mach speed drops below 0.05 Mach. Mach values between 0.05 and 1.0 can be displayed. A low airspeed awareness indication is displayed in the airspeed scale when the airspeed is near the stall speed for the existing configuration. The indication is white when speed is between 1.23 and 1.13 of Vs. The indication is amber when the speed is in the 1.13 Vs to Vs range. The stick shaker may be activated when operating in this range. The indication turns red when the airspeed is at Vs. The stick pusher will activate. Current airspeed is displayed in the middle of the speed tape. The indication is green when the airspeed is within normal ranges. It turns amber when the airspeed reaches VMO or MMO. The indication turns red at airspeeds above VMO or MMO. If your speed goes into the amber, the digits on the pointer turn amber. If it goes into the red, the digits turn red. If the trend vector goes into VMO, MMO, or below VS, the speed readout turns amber. Airspeed between 40 knots and 400 knots are displayed with a 1 knot resolution. In the event there is a difference of more than 5 knots between both primary flight displays, and amber IAS annunciation appears adjacent to the top of the speed tape on the left-hand side. The annunciation flashes for 10 seconds and then is displayed steady. Altitude information is displayed on the altitude tape on the right-hand side of the PFD. The current altitude window indicates the aircraft's current altitude with a resolution of 20 feet. The altitude is displayed in green. The white double-line altitude chevron indicates the altitude in multiples of 1,000 feet. The single-line chevron indicates 500-foot increments. The altitude tape moves in relation to the current altitude window. The tape is gray while the scale is white. The altitude tape moves in relation to the current altitude window and displays a range of plus or minus 550 from the aircraft's current altitude. The altitude tape can display altitudes between minus 1,000 and 60,000 feet with a resolution of 100 feet. The altitude tape also displays the Flight Guidance Controller pre-selected altitude, the respective pre-selected altitude bug, and the altitude trend vector. An altitude trend vector indicates the altitude the aircraft would attain in 6 seconds if the current vertical speed is maintained. The trend vector is displayed as a vertical bar that extends from the center of the altitude tape. The tape extends upwards for climbs and downwards for descents. A raster band is displayed on the bottom of the altitude tape when the aircraft is below 550 feet radial altitude. This band represents the ground and is provided by the radial altimeter. The band covers the lower half of the altitude tape when the aircraft is on the ground. The barometric setting is displayed under the altitude tape. The digits are displayed in cyan while the label is white. Altimeter settings between 16 to 32 inches of mercury or 542 to 1083 hectopascals can be set. The barometric settings are controlled by the two controls located on the bezel of each PFD. The Inches HPA button enables the crew to select the barometric setting measurement. Pressing the button cycles between inches of mercury and hectopascals. Click on the Inches HPA button to change the barometric reference. A standard button can be pressed to adjust the barometric altitude correction to the standard value of 29.92 inches of mercury or 1013 hectopascals. Click on the standard button to set the standard value. Barometric settings are selected by rotating the baro knob. The values are increased by rotating the knob clockwise and they are decreased by rotating the knob counterclockwise. When there is more than a 200-foot difference between the two PFD altitude annunciations, an amber altitude annunciation is displayed near the top of the tape, immediately to the right. This indication flashes for 10 seconds and then becomes steady. The vertical speed indicator displays the aircraft's vertical speed as well as pitch commands from the TCAS system. Vertical speed indication is displayed in both analog and digital format. A green pointer indicates on a white scale the aircraft's vertical speed between plus or minus 3,000 feet per minute. The scale has marks every 500 feet. However, the scale is nonlinear in that it provides increased resolution around zero vertical speed. A digital vertical speed indication is displayed inside the vertical speed analog indicator. The aircraft's current vertical speed is displayed in green with a resolution of plus or minus 50 feet. The digital readout only displays with a rate of climb or descent greater than 500 feet per minute. In the event of an invalid vertical speed, both the pointer and the digital indication are removed from the display and a red boxed VS label is displayed. A radial altimeter system provides the aircraft's altitude above ground level. It is used for low altitude awareness and supplies decision height information on the PFD. The radial altimeter system consists of a radial altimeter transceiver, a control knob button combination on the display control panel, and two flush-mounted antennas. One antenna is used to transmit the beam. The other antenna receives the returned radio wave. The elapsed time is used to derive the aircraft's altitude above ground level. The selected decision height is displayed in cyan in the lower right-hand side of the PFD. A white RA label indicates that the preceding value is the selected decision height. Altitudes between 5 and 999 feet can be selected. The decision height is set by rotating the decision height setting button located on the associated display control panel. For altitudes below 200 feet, the decision height can be selected with a resolution of 5 feet. For altitudes above 200 feet, the resolution is 10 feet. The decision height indication is boxed when the aircraft is within 100 feet of the decision height. The control panel on this screen is interactive, so you can set the decision height. The decision height indication is removed by setting it to 0. In the event of a radial altimeter failure, the decision height indication is replaced by amber dashes. The aircraft's current altitude above ground is displayed in a white box located in the lower half of the attitude indicator. The altitude is displayed in green digits. The radial altitude indicator can only display values between 2,500 and minus 20 feet. For altitudes below 200 feet, the radial altitude is displayed with a resolution of 5 feet. For altitudes above 200 feet, the resolution is 10 feet. In the event of a radio altimeter failure, the radio altitude digits are replaced by an amber RA and the box outline turns amber. A white box with an amber minimum is displayed above and to the right of the radio altimeter display when the aircraft's radio altitude is within a certain range of the decision height. The minimum label is displayed when the aircraft's radio altitudes is at the selected decision height. The display flashes for 10 seconds, then becomes steady. The RA minimum annunciator is armed when the aircraft is in flight, a decision height is valid and is being displayed, the radio altitude is valid and is greater than 100 feet above the decision height setting for at least 5 seconds. The RA minimum annunciator is removed from the display in the event of a radio altimeter failure. An amber RA label is displayed in the lower left-hand side of the PFD when there is a difference between the on-side and cross-side radio altitudes. This difference varies with the radio altitude. The radio altimeter system is tested by pressing the test button at the top of the decision height setting knob. Pressing the test button on the ground tests the IC600 system. Pressing the button while in flight tests the associated radio altimeter system. Pressing the test button while on the ground activates the IC600's first level test. Pressing the button for more than 6 seconds activates the IC600's second level test. The IC600 returns to normal operation after the test is completed. Pressing the test button while in flight tests the associated radio altimeter system. To perform the test button must be kept pressed in and the decision height must be set to 200 feet. During the test, a magenta test is displayed in the upper left-hand side of the PFD. The radio altitude indicates 100 plus or minus 10 feet. An amber RA comparator label is displayed in the bottom left side of the PFD, and an amber minimums label flashes for about 5 seconds and then becomes steady. We will now look at standby instruments. There are two options for standby instruments, either conventional instruments or the Integrated Standby Instruments System, or ISIS. Standby instruments consist of the magnetic compass, a standby airspeed indicator, a standby altimeter, and a standby attitude indicator. These standby instruments provide flight data information in the event of a complete loss of the EFIS displays. All of these instruments are available in the event of a complete electrical failure. A magnetic compass is mounted at the top of the windshield mounting bracket, in between the two pilot stations. The aircraft's magnetic heading is indicated by the lubber line. Two calibration cards provide correction values to be applied to the indicated magnetic heading to derive the actual magnetic heading. The calibration card to be used for normal operations is located above the compass. The second calibration card is located on the captain's side of the main panel. The reason for this second card is that there is a different electrical field when the generators are off and the calibration numbers are different. The standby magnetic compass requires 5 volts DC for the internal lighting only. The standby compass does not require electrical power for its operation. The standby airspeed indicator displays a continuous indication of airspeed derived from the number 3 pitot static tube. The aircraft's airspeed is indicated by the pointer. The standby airspeed indicator does not require electrical power to operate. However, internal lighting does require 5 volts DC. The pressure The ICES integrates all the conventional instruments depicted previously into one instrument. The ICES provides attitude information, standard or barometric corrected altitude and the associated barometric pressure, indicated airspeed and indicated Mach number, VMO, skid slip information, and magnetic heading from AHRS-1. ICES is powered by 28 volts DC power supplied by the Essential DC Bus 2. In the event of an electrical emergency, the ICES will operate using electrical power from the batteries for a period of approximately 40 minutes. The ICES is powered as soon as the batteries are switched to auto. At that point, the ICES starts a 90-second alignment phase. During the alignment, an initial 90 seconds flag is displayed on the ICES screen. The 2 push buttons labeled plus or minus are used to adjust the brightness of the ICES display. The pitch scale has white reference lines every 2.5 degrees between minus 30 degrees and plus 30 degrees, and the associated pitch angle values in white every 10 degrees between minus 50 degrees and plus 50 degrees, and at plus or minus 80 degrees. Beyond plus or minus 30 degrees, red chevrons are displayed to indicate excessive pitch angle and the direction to follow in order to reduce this excessive pitch angle. The cage button provides a fast erection function and resets the attitude. This cage function is inoperative during the initialization mode and should only be used while in stabilized flight. When the cage button is pressed for more than 2 seconds, the horizon is reset to 0, and an attitude 10-second warning flag is displayed. A failure of the attitude function is indicated by the replacement of the normal attitude information with a black background and an attitude flag. The ICES displays altitude data provided by Pitot Static Tube 3. This altitude is displayed in tape format. The barometric reference is changed by means of the barometric knob. The standard button sets the ICES reference barometric pressure to the standard value. The altitude tape is removed and an altitude flag is displayed in the event a failure of the altitude function has been detected. The ICES displays airspeed data provided by Pitot Static Tube 3. Airspeed is presented in tape format. Digits of the airspeed tape and Mach number display are green when the airspeed and Mach number are lower than VMO/MMO, and red when the airspeed and Mach number are equal to or greater than VMO/MMO. In the event of a failure, the airspeed tape and pointer are removed, and a speed flag is displayed. Other information provided by the ICES consists of magnetic heading and lateral acceleration or slip indication. Two clocks provide GMT and local time, elapsed time, date, flight number, and chronometer functions. There is one clock at each pilot station. The captain's clock is powered by Essential DC Bus 1, while the co-pilot's clock is powered by the number 2 DC bus. Clock information such as date and time are stored in memory when the aircraft is shut down. This memory is powered by an internal lithium battery, and clock information is updated when the aircraft is powered up. The only information that is not retained is elapsed time and chronograph information. Elapsed time and chronometer indications are displayed in the lower indicator. A chronometer pointer also indicates the chronometer seconds. The elapsed time and chronometer indicator displays elapsed time from 0 to 99 hours and 59 minutes. The elapsed time represents flight time, and it starts counting when the aircraft takes off. The elapsed time can only be reset when the aircraft is on the ground. Chronometer minutes from 0 to 99 minutes can also be displayed. When the chronometer clock function is in use, the elapsed time continues to accrue. The chronometer button starts, stops, and resets the chronometer indicator and pointer. Pressing the chronometer button cycles through all three functions. The first press starts the chronometer. This removes the elapsed time, resets the counter to 0, and starts the chronometer. The second press freezes the elapsed time and the chronometer indicator. The third press resets the chronometer. The pointer returns to 0 and the elapsed time is displayed. On the ground, the elapsed time is also reset to 0. An alternate chronometer button is located on the control wheel. This button functions the same way as the one mounted on the clock faceplate. The selector on the lower left-hand corner of the clock is used to set the date or time or select the information to be displayed in the GMT, local, date, and flight number indicator. Time can be set by placing the selector to the set position. Pressing the elapsed time button causes the selector to cycle between GMT minutes, GMT hours, local time minutes, local time hours, days, months, and years. Once a function has been selected, it flashes on and off to indicate that it can be changed. The value is incremented by pressing and holding the chronometer start button. The selected digit changes at a rate of 1 unit for every half second the button is depressed. The units can be incremented 1 unit at a time by pressing and releasing the chronometer start button. GMT time is displayed on the clock by placing the selector to the GMT position. GMT is displayed in 24-hour format. A dot above the GMT label indicates that the displayed time is GMT. Local time is displayed by placing the selector in the local time position. Local time is displayed in 24-hour format. A dot above the local label indicates that the displayed time is local time. The date can be displayed by selecting Date. The date is displayed by alternating between month, day, and year every second. The flight number is displayed and set by placing the selector in the flight number position. To set the flight number, place the selector to the flight number position. Press the elapsed time button successively to select the digit to be set. Pushing the elapsed time button cycles through thousands, hundreds, tens, and units. Once a digit position has been selected, press the chronometer button to increment the selected digit. Pressing and holding the chronometer button increments the digit at a rate of 1 unit per half second. Momentarily pressing the chronometer button increments the selected digit 1 unit. A flight number between 0 and 9,999 can be set. The Flight Data Recorder, or FDR, is located in the rear electronic compartment. It records aircraft system parameters automatically from engine start to engine shutdown. The FDR is powered by the Essential DC number 1. The Flight Data Recorder system consists of a solid-state flight data recorder, an underwater locator beacon attached to the Crash Survivable Memory Unit or CSMU case, one triaxial accelerometer, 5 wire-wound precision potentiometers, a 5G impact switch, and 2 data acquisition units or DAU. The FDR self-tests during power-up and continuously thereafter. A DFDR failure message is displayed in the event a flight data recorder failure has been detected. Data is recorded when the red beacon switch is placed to on or once the aircraft is airborne. The flight number must be set on the captain's clock so that it can be recorded along with the system data. This concludes the Flight Instruments module.